So this has got a part A here and a part B. If you're going to lift the box 1 meter, then you're just going to do the potential energy. The U of gravity is mgh, right? And so you can solve for mgh. You'll get a number right there. Now the next question is that how much force do you need to apply on a frictionless surface to get it to the top? What's kind of important is you've got to figure out how long this is. How long is the hypotenuse of this triangle? You'll use SOHCAHTOA. It'll be sine something, all right? And you want to solve, and it's going to be a weird one. Oftentimes when we do this, sine 30, if you think about it, is equal to 1 over h, and you've got to solve for the h, not that. Usually we have that number at the bottom, we just multiply. There's not a multiplication, because the question it's kind of asking is how much force is required to go push the bad boy up. But if you say this is mgh, that's the energy. Okay, we're going to set that equal to the work equation. So that's energy. This is energy, right? Gravitational potential energy, and you have to do some work, and the work is equal to the force times the distance. Now the distance is this height, or actually I shouldn't call that the height. It's 1 over, yeah, the hypotenuse. That's what I meant. For h for h. That h is this d right here. The work will be this number right here. This is the energy. That is equal to the force times whatever you solve for here, and then you can find the force.